Everyone talks about scaling energy to scale AI. Almost no one talks about the energy that scales humanity. What are we missing?
Economic growth basically tracks reduction in the price of energy. The opportunity cost of a day of delay in the US AI industry is on the order of $60 million today. In 5 years, these data centers become desirable local sources of economic prosperity and relatively cheap power.
Are we ever gonna reach a point where energy is as abundant as basically being free?
Semi-limitless quantities of solar electricity for $10 a megawatt hour.
What does this cheap and abundant energy unlock in like the everyday life of the average person?
Mark III aircraft powered by large tanks full of liquefied natural gas. It's just a much more exciting and compelling future than one where we kind of shiver in the winter and live on UPI.
Is US going to go full circle from Standard Oil and US Steel ruling the economy through to Google and Facebook now, back to industrial giants being really the main game?
The regulatory state not only is indifferent to you, they actually hate you.
Is Europe going to flip and become a developing country? How does this play out?
We've had this technology for 10,000 years, and we've decided to make it artificially scarce for no reason, and it is literally destroying our civilization.
What's the next $10 trillion company like Tesla or like SpaceX that makes hardware that's going to become uniquely possible by cheap and abundant energy?
Plastics themselves are made of hydrocarbons, so we're going to continue to need a lot of them forever. But fundamentally, we just have to make more energy.
Hi, Casey. Welcome to Accelerate Bio. So everyone talks about scaling energy to scale AI. Almost no one talks about the energy that scales humanity alongside it. What are we missing?
Well, certainly jumping right in without a warm-up, and it's great to be here. I think that the economic utility of the marginal kilowatt hour devoted to inference with AI data centers, even with our current relatively primitive LLMs, is demonstrably greater than the utility of the marginal kilowatt hour consumed for heating or whatever. And as a result, we should be pretty circumspect about how we structure our electrical system to ensure that that all the various parts of our economy are getting a fair shake. But fundamentally, we just have to make more energy.
You're saying the utility of the incremental kilowatt hour for AI right now is much greater than for other human-related use cases. Do you think that's true just in this moment in time, or is it going to be true going forward?
Well, I think it's going to be increasingly true over time.
Is there any point at which we come up with more energy use cases outside of UI where it reverses, or is this just an exponential slope that will continue climbing up?
Well, I think that conventional utilities and so on have particularly in the West, not seen kind of robust demand growth much over the previous few decades, which is may as well be forever as far as the memories of the people who work at those organizations go. Until initially a little bit of nascent hashtag Reindustrialize going on in the United States, but more prominently, and I guess in Europe, deconstruction of existing nuclear power plants. But more recently, I think the explosion of interest in AI development has really kind of laid bare the extremely steep elasticity of supply, which is to say that significantly more demand comes online, and the market is extremely slow to expand to meet that demand. That said, the sluggishness of the electricity market, in particular in colder climates, was really beginning to cause problems all around the world, well before AI was on the scene. And I think when we think about human welfare in general, AI demand and the kind of hundreds of billions of dollars behind that being the tip of the spear to force a modernization of these grids will ultimately prove to be a good thing for every consumer on that grid, not just the leading echelon.
So you're saying AI is the catalyst that forces us to wake up when it comes to energy production, energy modernization, but there will be a lot of other downstream effects that will benefit from this outside of AI.
I think that's a fair assumption because it's very hard to know for sure. But I think over the past 50 years, there have been various leading use cases for, say, microchips, for example, with many ancillary benefits along the way. Right. So for example, cell phones drove adoption of MEMS sensors, and compact GPS receivers and stuff like that. And yet those same component packages found their way into, at first, consumer-grade drones and other sensor packages and satellites and things like that as well, which perhaps independently could not have developed that same degree of technology because they just didn't have as wide a user base to begin with.
You mentioned reindustrialization, which goes well beyond AI. So just to double click on that, what other specific industrial use cases of energy outside of AI are you excited about right now?
Yeah, well, my day job is the founder and CEO of Terraform Industries. It's a US-based synthetic fuel technology startup company. Synthetic fuel, what is that? Well, the chemical nature of gasoline and natural gas and so on is the same, regardless of whether it comes out of the ground or from a bio-waste processing facility, or in our case, from a kind of 21st century solar photovoltaic powered, highly advanced synthetic chemistry reactor. And so that's what we're working on. And we ultimately think this will give humanity the ability to couple the kind of material side of our economy, which is to say industrial production, manufacturing, liquid and gaseous fuels directly to the solar technology wave. And this will be necessary. Otherwise, necessarily fossil-derived fuel sources and their dependent industries will be left behind.
Can you tell us why are synthetic fuels or liquid fuels still important in a solar-first economy?
Yeah, of course. I mean, we continue to see a gradual electrification of our economies, and obviously some countries are further ahead than others. But it's undeniable that hydrocarbon-based, in particular, fuels have really transformational utility for a wide variety of extremely highly energy-intensive use cases. So I can imagine a future. In fact, I just put out a blog post a couple of days ago talking about where I think this is going. And so it would not surprise me, for example, to see that ultimately heating, cooling, and ground transportation will go electric. But at the same time, I expect that aviation, long-distance shipping, industrial heat, chemical synthesis, and so on necessarily will have to remain powered by hydrocarbon fuels and probably pushing towards LNG in general, actually. It should be an exciting future, right? You think 50 million people worldwide today enjoy the privilege of aviation. And if we want to think forward to a future where 500 million or 5 billion people can enjoy that same privilege, it'll necessarily have to have a lot more fuel available. And at the same time, kind of the power law distribution of technology and wealth within that population would imply that you and I and the 50 million may by that point be able to enjoy supersonic transportation, which itself is maybe 10 times as energy intensive again. So you can think of a highly futuristic high-speed Mark 2.5, Mark 3 aircraft powered by large tanks full of liquefied natural gas, running 21st century high-efficiency hybrid electric turbine jet engines or something like that. It's just a much more exciting and compelling future than one where we kind of shiver in the winter and live on UPI, and all possibility of human flourishing and merit and further technology development is curtailed in favor of some kind of arbitrary metric.
I can definitely agree to that. But just to elaborate on the technology first, so is there any alternative future in which all of these aviation and industrial use cases are just powered by electricity directly instead of LNG, or what are the fundamental constraints here?
Yeah, so it's not that difficult to transport chemical energy, LNG and gasoline, kerosene, and so on. And I think that at scale, it probably makes sense to produce those fuels with local electricity. That is, some captive solar photovoltaic power plant with the modular chemical plants directly adjacent to them producing these fuels, move them through pipelines, and then plug them into existing industrial facilities. So we don't have to rebuild all our factories, for example. And then if you're imagining a factory that produces plastics, for example, it's very hard to imagine how that could be operated on pure electricity, because plastics themselves are made of hydrocarbons. So, the things that you and I enjoy, the very medium by which we're conducting this conversation, and everything that our respective webcams can see in either direction is essentially downstream of the petrochemical industry, which itself is based on hydrocarbons. So we're going to continue to need a lot of them forever.
But you're talking about the materials that we need to use to make this product. So that's one side of the equation. but you're also talking about the energy that powers these processes, requiring hydrocarbons instead of electricity.
Yeah, I mean, I'm not the world's greatest expert in industrial chemistry, but there are a handful of processes that require high amounts of concentrated heat. And there's always ways of doing it electrically, but at the end of the day, the process that delivers the greatest step change increase in the value of the precursor materials and then passes on most of that value to customers is the one that will ultimately prevail in the marketplace. And that's the way it should be, right? Now, civilization is strong when we have copious supplies of cheap steel, not when the steel is made through some arbitrary process for aesthetic reasons.
So you're saying we are not going to get to the same efficiency or to the same price point of industrial production of steel using electricity at any point in the predictable future?
I'm just using steel as an example. I think maybe cement's an even better example. Efficiency and price point are two different things, right? Or rather, price point, you could think of that as some kind of weighted average over capital efficiency as opposed to electrical efficiency. And it's true that for some processes, they're pretty closely aligned, but in others, they're not. We've seen a number of policy missteps in recent years, kind of conflating one with the other. At the end of the day, consumers demand and must have supply of energy that's not only cheap, but getting cheaper at a predictable rate over time. And to a very, very good approximation, economic growth basically tracks reduction in the price of energy. So the nations on Earth that have cheap energy are generally, basically almost all of them uniformly very wealthy. And kind of regardless of other aspects of their governance. And meanwhile, the nations that do not have locally available cheap energy are almost always much, much poorer, kind of regardless of how good the governance happens to be. And the number of exceptions in either direction is vanishingly small.
And you're saying we are not going to arrive at a point where we have cheap and abundant energy purely from electricity.
Yeah, I mean, I think that electricity will, like solar photovoltaic electricity, will ultimately be the cheapest form of energy. Whereas right now, there's something like a 2 or 3 to 1 penalty to convert energy, like thermal energy in the form of coal or oil, into electricity, thanks to the inefficiencies of power plants. In the future, it'll be 2 or 3 to 1 in the opposite direction, which is to say you can get, I don't know, pick a number, semi-limitless quantities of solar electricity, at least during the day, for $10 a megawatt hour. And if you want it 24 hours a day with the help of a battery, it might be more like $30 or $50 a megawatt hour. But you can convert that into natural gas or into oil at a price that's comparable to today's prices. So that will create a strong economic forcing function to transfer what processes can be transferred to electrical power. But this is not really something that requires centralized top-down control or our analysts at the Rocky Mountain Institute or the IA or whatever to kind of sit there with a paper and pen and make a successful prediction. All they need to do is ensure that the basic policy positions are in place to make sufficiently cheap energy over time, and let the market figure the rest out.
How far are we in terms of technology from a scenario where it is viable and affordable to convert solar energy and water into synthetic hydrocarbons?
Yeah, we're probably closer than most people think. Actually, probably most people don't think about it a whole lot. And that's actually a nice thing, right? Like most of the magical technology we depend on, you don't have to understand how it works to use it. But to get concrete for a second, synthetic fuels have been an area of active research and development for more than 100 years. And indeed, like we're not the first company to even make synthetic fuels with solar power. That's been done one way or another in various pilot plants for almost 20 years. But the challenge is to do it at a price that makes sense to consumers, which is to say cost parity with the marginal fossil supplier. And I think for liquid fuels, we're actually very close. Like within some markets, I believe our current process would be slightly cost advantaged. With gas, like natural gas, probably a few more years, just to kind of get the additional reduction in solar cost, and then pass it on to consumers. But certainly, like I have a few gray hairs here. I expect this to be done before I'm completely gray.
Let's hope that's the case. So we mentioned AI, we mentioned industrial production, but fundamentally, what does this cheap and abundant energy unlock specifically in like the everyday life of the average person over the next 10 to 15 years? what is like one thing that people can visualize?
Yeah, well, 10 to 15 years is not a huge time horizon there, but I think it's probably instructive to look back over the last 10 to 15 or 20 years. And as recently as 2006, 2007, the EU and the United States were close to economic parity. And now it is very much not the case. Over the course of the intervening years, the United States economy has almost doubled in size and the EU economy has been pretty flat. And so when I was a young man, it could honestly be said that the quality of life in both places was roughly equivalent. And I think it's certainly the case now that the people in the United States are doing better, and that better quality of life is available to a larger slice of the overall population with a wider variety of skills and talents and so on. And so that's kind of the first order picture we're looking at here, which is cheap energy allows even people as mediocre as me to have an excellent quality of life. So that's a super important thing. And then long term, you say, well, in the United States at least, it's pretty common to have cars and air conditioning and so on. So you say, well, like, what else could you spend power on? And it's true actually, like, putting more lights in your house won't drastically increase your power consumption. Driving an electric car won't drastically increase your power consumption. Having a larger house and then air conditioning it more in hotter climates will, or heating it more in colder climates will increase your power consumption, reasonably, quite considerably. And so, for example, if we saw large scale deployment of air conditioning in Europe, for example, we should expect to see a much larger commensurate increase in power consumption in the summers. But then you say, like, let's think big. Let's think much beyond that. How do we get to 10x? How do we 10x our per capita power consumption? And I think there's really only two ways to do that. And obviously, 10x is a lot, right? So we could double our per capita consumption of cement and steel, and it would hardly really make a dent. The really, on a per capita basis, energy intensive things that people do, aviation, transport, like flying aircraft. Okay, so more people flying more often at much higher speeds over longer distances could fairly significantly increase fuel consumption. There's a lot of headroom there, a lot of energy consumption headroom there. If you think about the total energy consumption in the aviation industry, you're on my per capita consumption of energy within aviation compared to the median human, for example. There's probably 1,000x increase on the table there, and then the other one, of course, on a per capita basis, is slightly cheeky. Is AI compute, because of course AI compute is about making more heads. But if you allocate the increase of digital intelligence on a per capita basis to biological humans, then the overall power consumption in that sector of the economy will continue to grow pretty explosively, I believe.
What was the driving force behind the most recent 10x? Was it cars and more air conditioning, more home appliances, more industrial production?
I think just electrification in general, right? So it wasn't that long ago that most houses didn't have electrical service, and most people. So we had electricity, and electricity was invented and rolled out in the 1880s in parts of the United States, but primarily in inner city areas and mostly for industrial applications. So like your factory would have a local electricity generator, local power plant that would operate things within the factory. But when you went back home, you might have to rely on kerosene lighting or something like that. I think that's most of the picture. But actually, in some parts of the world, in Europe, for example, per capita or average power consumption has increased by about a factor of 20 since the Industrial Revolution, whereas in the United States it's closer to 100. So maybe Europe is still in the process of metabolizing that second 10x. The first 10x, of course, being the introduction of like large scale mechanization, trains and mechanization of factories and farming and stuff like that. So big increase on top of what we could manage with, say, humans, mostly humans, but some horses and stuff as well in, like, let's say 1780.
By the way, if you're enjoying this, hit subscribe. We drop a new episode weekly, exploring how AI, biotech, and human enhancement are shaping the future. And if a friend would love this too, send it their way. It really helps us keep going. Now back to the pod. So we did a 10 to 100x by going from horsepower to electricity and mechanization and industrial production and the current transportation we have. And then the bull case for the future, the next 10x is, like you say, aviation. So maybe everybody can travel by airplane. I guess by extension, that's space travel eventually. And then AI. So that means everybody has got access to personal artificial intelligence, or I guess the proportions of AIs, non-human intelligences in the economy are, several orders of magnitude larger than right now.
Yeah. So we could 10x our current electricity consumption with AI, but that would probably entail a much larger than 10xing the size of our economy. Right? If you think about like what you get for what you give. And as far as spaceflight goes, yes, of course, per capita fuel consumption of astronauts is extremely large, but there aren't that many of them. In fact, this picture behind me is every flight of humans into space from the United States up until the introduction of the Dragon capsule. So, and since then, there's been about 50 more people in space. So that's, I don't know, a total of 500 or so in space. So you could 10x global aviation. That would be marginal 450 million people flying. And you could 10x the size of the astronaut corps, and you'd end up flying like on the order of 100 people a year. So it's we have ways to go as far as flying to space goes.
I guess we have to do several 10x's on that front.
Yeah, I mean, ultimately, I don't know. I think maybe I was born too early, but I could imagine a world where 1 million people are flying in space, but 1 billion is a lot larger number than that. So I don't know. We'll see how we go.
These are the things we can unlock with cheaper and more abundant energy. Do you think? Are we, like, to be really sci-fi, to really project into the long-term future, are we ever gonna reach a point where energy is as abundant as basically being free, or like the cost of energy not being a factor at all? Or is it just gonna, or are we just continually scaling the slope of how much energy we get per dollar?
You could probably make an argument that like the dollar has kind of been denominated in oil for about 100 years at this point. But maybe the economic productivity we get per dollar of oil has increased, something like that. And I think it's actually maybe doing our current listenership a disservice to imply that that electricity is not already practically free. So you say, like, what does it mean when something is post-scarcity? And in my view, it means it comes out of the wall, right? So the data bandwidth we're consuming today to have this phone call, it's post-scarcity. It's coming out of the wall. Somewhere in my house, there's a Wi-Fi router that's doing this work, and I don't think about it. I pay $50 a month, and there's essentially I never run out, right? No matter how much I use. So I don't bother hoarding it, right? The same goes for water, right? Water comes out of the wall of my house. I don't store it in my house. I don't store large volumes of water just in case the water coming out of the wall stops. Same with electricity. I don't store power coming out of the wall, and my electricity bill is a tiny fraction of my, say, daycare bill. So it's for 99% of the things that I use energy for, it's essentially free already, which is in itself an astounding achievement, right? It was not that long ago that our respective ancestors were shivering and freezing to death and starving and so on for a lack of even digestible energy that they could put in their mouths or their children's mouths. And nowadays it's at the point where I can leave all the lights on or turn them all off, and it really doesn't make a difference. Isn't that amazing, right? Or I can air condition my house down to 68 or 72 or whatever. It doesn't really make a difference as far as energy consumption goes. I live in an old house, and I could rip the walls apart and insulate them, but there's not really, it would cost me $1,000 or $5,000 to do that, and it might save me $500 a year in terms of cooling costs. So kind of what's the point? So it's energy, the contribution of energy to the bottom line for anything that you consume right now. I mean, for people in our class, at least, who are like relatively well off, it really only bites, I think, when you buy an airfare. Does it make sense? Like if I fly back to Australia, it's a couple of $100 of that ticket. It's just paying for fuel, which is kind of astounding in itself that you can purchase your share of the plane for only a couple of $100.
It's definitely amazing when you compare to how it was a couple of decades ago. And you're right. So energy at the moment does feel effectively free, at least to a population in the developed world, in the US.
And it's not that the energy got cheaper. If anything, it got more expensive, right? And like versus inflation, electricity provisioned by the grid in most places has gotten more expensive in the last 30 or 40 years. But at the same time, we have gotten wealthier still by comparison, almost always. I'd say like there's exceptions in parts of Europe, but or for retirees or people on fixed incomes, for example. But for my parents, it was actually worth their while to turn the lights off. The lights were less efficient back then as well, but it was worth their while to turn the lights off and save some power. But for me, at least, that cost is kind of in the noise.
Okay, so energy feels free, at least to people in the developed world. Eventually, it will feel free to every individual, but it definitely doesn't feel free to, if we scale up and talk to companies running industrial production or governments, countries level. So are we gonna keep scaling it up so it effectively feels free to on those scales as well?
Yeah, it's an interesting point. Actually, like, here's a crazy thing. You go and drink a can of Coca-Cola and you throw the can away after you're done, and maybe you recycle it, maybe you don't. But like consumer disposable aluminum was, or aluminium if you prefer, was invented in the 1950s. But the Washington Monument itself was capped with aluminum because only like 100 years before, that was one of the most valuable metals there was. Like absolutely astounding. Like aluminum is basically condensed electricity, and it's so cheap that despite the fact that it's the single most expensive thing about a can of Coca-Cola, you throw it away after you're done. And I would say that actually, even for the people in the world who are less well off than us, energy is a lot cheaper than it was. The last naturally occurring famine, I think, was in 1946. Right? There have been famines since then, but they're due to people shooting each other or using hunger as a weapon. They're not like, oh, we had a bad harvest that year, or like, the nitrates came in poor or whatever. It's since we invented fertilizer and
yes,
irrigation and pest control and a few other things like that. It's and so like that first primary form of energy, like not being hungry in winter, has almost passed out of human memory, which is kind of astonishing in a way. No, so you ask, what would it take before the industrialists stop complaining about energy being expensive, or at least the hyperscalers? And the thing is, like, the expense that they're seeing for energy is not that like their per megawatt hour cost is too high. It's that when they talk to their local utility, who has a government granted monopoly concession to provide power in a given area, and they say, yo, dog, I would like 11 bajillion gigawatts of power. Please make it happen. The answer they get is not, well, that's going to be a lot of money. The answer is, that's going to be 5 years. And that is hugely expensive. The opportunity cost of a day of delay in the US AI industry is on the order of $60 million today. There's a staggering statistic for you. So every day that our incumbent energy suppliers are unable to provide power is a $60 million cost to the industry as a whole, which is kind of bananas. And so that's why we're seeing, these AI hyperscalers now for several years have been looking closely into doing what we used to do 150 years ago and build their own captive power plants. And they're probably going to have to continue to do that. The amount of power they're using means that just the cost of building new transmission and then transporting the power from incumbent power plants, which are generally pretty much at capacity, to them is too high, which is really exciting. I mean, like, for now it's mostly gas. I think in the future we'll start to see a trend towards solar and batteries as well. But it means that if you say, well, where in my economy are power plants being built? Be like, well, they're being built on the AI hyperscaling data center. Okay. And at what scale are they being built there? Well, many, many gigawatts a year. That's cool. Okay. Do they need all that power? No, they actually overbuild it quite a bit just to make sure. Can we buy the spare power? Yeah. And so it's kind of crazy that, like, right now the story is, well, you can't site these data centers in Virginia anymore, or the Southeast or parts of California or something, because they demand too much power from local consumers who then see their bills affected. But I think in probably 5 years or so, we'll see that script flip, and instead these data centers become desirable local kind of low drama sources of economic prosperity and relatively cheap power.
And that's going to make energy cheaper for everyone, but still not effectively free. So you said for hyperscalers, the energy is a very small cost compared to everything else, which is true, but those are edge cases. Yeah. When we talk about industrial goods, so for example, this microphone, I think majority of the cost is from the energy that it takes to manufacture and assemble it and ship it to me. And you said US dollar is denominated in petroleum, basically, which is energy. So if we do get to a point, to a scenario where energy effectively feels free for industrial production, I feel like the world would look like a very different place, but we're probably quite far from there.
Well, the challenge there is not the cost. I mean, like, there are a handful of industries like aluminum production, right, and the whole Hero process. So I've got some aluminum right here. Here's some aluminum. Here's the Carl Cawthon Friendship aluminum cube. And something like 30% of the cost per ton of the aluminum is embodied electricity cost, and that's enough that aluminum smelters will tend to preferentially site themselves in locations with reliable supplies of cheaper electricity. Say, for example, Iceland. But in Iceland, we're still talking $60-70 a megawatt hour. It's not astonishingly cheap. It's maybe 2 or 3 times cheaper than your average grid supply cost in your middle American city somewhere. I think it'll be a very long time before like my local utility sends me a bill saying, you pay $0 this month. Just because like the irreducible costs, I mean, most of the cost you pay in your utility bill is actually transmission and distribution anyway. You're paying for the upkeep of the power lines, which itself is afflicted by Balmore cost disease. So that's kind of a challenge, right? And actually, that's part of the reason why, particularly in Australia, actually, of all the kind of Western developed economies, you're seeing large-scale deployment of solar batteries behind the meter on houses and ultimately grid defection, which is kind of a funny story in itself. But initially they had net metering, and they're like, oh, it's no good. People are making too much money. It's stressing the grid. So then they switched to a connection fee model, where if you want to be connected to the grid, you just have to pay like quite a lot of money and then use it or lose it. And people are like, I don't want to pay this money. So they just double the size of the solar array and then delete the grid connection. So you got a bunch of suburban houses with power poles right outside they're not connected to anymore.
So the future is decentralized, or at least in some parts of the world.
Well, I mean, there's a question you can ask. You say, well, what is the average distance that my electrons are traveling to me right now? And I can tell you that actually, because right now it's in the evening in Los Angeles. And so there's a bunch of gas production peaker plants here in LA. The closest one that I know of is about 5 miles away. So that's probably where my power is coming from. But there's also a lot of batteries now that are discharging. In fact, I could pull up the California ISO dashboard and tell you exactly. But 85 years ago, when they built the Boulder Dam, which is now the Hoover Dam in Las Vegas, they invented high voltage power transmission technology at Caltech to move that power from Vegas into Los Angeles, hundreds and hundreds of miles at high voltage. And so those electrons traveled quite a long way. And if you say, well, even if I consume more power in the future, what is the average distance those electrons are likely to have traveled between the point of production and the point of consumption? And I'm 100% certain that distance is not only decreasing over time, it's actually decreasing at an accelerating rate. And let's pick a number. I say in 15 years, it'll have reduced by more than a factor of 2. Which in turn is basically just a leading signal on the ongoing devaluation of extremely long distance power transmission. Yes, you'll still need your local distribution grid in most places, but you just kind of see a reduction of the intensity of the very long distance links. So maybe some bad analogy for this would be like, think about your local road networks, right? But before we started building all the freeways and highways and interstate highways and stuff like that. So you got road networks that cover the United States, but the quality and density varies. And there's no real kind of major arterials.
So you're basically saying the market forces that are driving cheaper solar, more decentralized, closer to consumer electricity production, and some other technologies such as the synthetic fuels that you're working on, as well as the demand from AI, are basically already making energy more ubiquitous and exponentially cheaper, and they're just going to continue playing out. And we don't basically need to do anything much to make this happen as a government or as a society.
No, I mean, I'd say like my wish list is always for more sane regulatory and permitting, right? So I mentioned Australia earlier. Australia's cost for rooftop solar is, I think, almost 10 times lower than in the United States. And there's no reason for that. It's the same technology. It's the same like guys crawling around on roofs, right? So it's just a regulatory hurdle there. But at the end of the day, the market mechanism, market forces are in place. And so the effect of inefficient regulation is that it slows things down, but it won't stop them. It's just a matter of time. So it's like, for how much longer do you want to be poor is kind of the question.
Is it really just the regulation, or are there some other bottlenecks here that we need to unlock?
No, I think maybe 20 years ago you could say, well, accelerating solar would still benefit greatly from like large-scale centralized government subsidies or something like that. But at this point, I think the value prop is very clear. And like one way you know that, for example, is that the countries that have, let's say, a very different regulatory regime. So like Pakistan, for example, so largely unregulated in terms of consumer electricity. and also like not much in the way of like heavy-handed government-funded subsidies for this technology has actually, partly as a result of the inherent unreliability of the legacy grid there anyway, seen an enormous explosion in the amount of solar and batteries deployed there. Again, for largely like local supply and demand, local consumption, maybe in like city block style local grids that have been set up. But it's all Chinese stuff, right? So buy any of 20 different brands of batteries and solar, and they all have mostly interoperable standards. You can plug them together and they all work. It's super fascinating, right? It's another example of like, the technology hides its complexity behind a very simple interface. It's far simpler to build a solar and battery power plant for your own house, for example, in downtown Islamabad or one of the outlying cities than it is to like, essentially build an electrical generator from an old car engine block and a motor and a few other bits of spare parts and get your uncle with a machine shop to help you plug it together. Like it's far simpler to do it with solar and batteries. There's no moving parts. It's plug and play.
How do you think this is going to play out? Are some of these third world countries, which are less stifled by regulation, going to just leapfrog some of the developed world? Is Europe going to flip and become a developing country? Like, how does this play out?
I think at this point, really, like the energy piece of like accelerating reindustrialization and reshoring manufacturing is really the West's to lose, particularly Europe, United States, and Australia, all of whom have respectable, if not excellent, solar resources, and modern governance and rule of law and advanced financing and highly educated, wealthy consumers and all the rest. And some of those pieces are missing in these other countries, but at least they can purchase solar and batteries from Chinese suppliers and install them locally and not have to, shiver and sweat through the days. So we will see. That said, I first traveled to Europe, I guess, as a young adult in the early 2000s, and I travel there not infrequently, and I'm deeply disturbed by the lack of dynamism and will to live that I see among the ruling class in Europe right now. I in some ways, this is the post World War II ruling kind of Bretton Woods scenario succeeded too well. It's easy to forget now, but Europe was by far the most violent continent on Earth for probably 2,000 years, for maybe 1,000 years, from the fall of the Pax Romana through to 1945. Just constant, endless wars. At times, 50 to 80% depopulation of certain areas just from death and starvation in war. And I like to think that at the end of the World War II, the United States took away all the toys and said, you have to play nice now. And 3 generations later, people have forgotten that, like, actually, if you want to live and survive and build a great life for your children, you kind of do have to fight and struggle a bit. Maybe not against your fellow human, but against the indifference of the universe.
I was born and raised in Europe. I don't live there anymore, but this definitely does concern me. And when I feel like the average person there, or when I talk to my parents, it's all Doomerism and climate alarmism, and it's all acceptance of not growing and really being clueless about, what are the long-term consequences of this. And I think you had that present in the US, and it is still present, but it has really flipped significantly over the past couple of years with drill baby drill and build and accelerationism.
Yeah, you don't need everyone to get on board.
How does it flip though? Like what would be the catalyst, and how likely is it to flip?
Well, you don't need that many people to really push it forward, right? But you do need to let them cook. You do need to get out of their way. And just one of the things that I find really disturbing about Europe is how difficult that Europe has chosen to make it for its entrepreneurial class to build. And we can see this in just like the evidence of like the lack of dynamism in the in the EU startup sector. I saw this insane stat the other day that the EU actually makes more revenue of fining American technology companies, at least for now, than they do in taxing their own. That's crazy. That's absolutely crazy, right? That's like colonialism all over again. And and you know, I have friends starting companies in the EU who have struggled to incorporate and raise money. And
well, I've been there and done that when it comes to both incorporating in Delaware and also living ultimately. And you're saying it doesn't take that many people, and I think you're right when you're talking about the number of entrepreneurs that need to build. But you're talking about top-down regulation that needs to change. And in the case of US, it did take a majority elected government to really start heavily pushing a reindustrialization policy. So that's really triggered by like mainstream sentiment of the majority shifting, right? There's not a small group of people just kind of doing what they want.
I mean, mimetically, sure. Like in terms of lots of people talking about reindustrialization, in terms of the Department of War and DARPA and friends, like putting some money towards primary production of rare earth metals on American shores. Sure, fine. But I think really, like the United States has had an extremely powerful manufacturing sector for over 100 years. And sure, it's shrunk and changed in some ways, particularly since maybe the 1970s, but it's still extremely powerful, right? As is Germany's and the UK's and France's in many ways, maybe even Italy's, northern Italy's. And then at the same time, I think, you know, credit has to be given to Elon Musk for taking his software-derived winnings and betting them on hardware and just throwing himself at the problem 80 hours a week for 20 years until he made some progress. Without which I think it would have been difficult to motivate that it was possible to do it all, let alone to do it without, you know, well, we don't do anything until the government writes us a blank check, and then we kind of futz around a bit. Here's a crazy thing. Like, look at China. Is China a great environment to start a business? Is China a place with like recognizably Western standards of like financial probity and like governance and the ability to IPO businesses and get money out and so on? No, not even close. Yes, it's true that the government provides relatively cheap credit in a unexchangeable currency, but the Chinese are also extremely entrepreneurial in their own way, and they understand that they may not express themselves politically or enjoy total economic freedom, but they can at least, you know, outbuild the West and build these fabulous factories and really get going. And if they can do it, why the hell can't Germany figure out how to do it? And, you know, Germany is still in the process of kind of negotiating who's going to take the biggest L in terms of auto unions, even as they close dozens of plants. Come on, guys, you can do better than that. Like you don't need the unions to argue over who gets the bigger piece of the shrinking pie if you're growing the pie.
You're saying this is a mimetic shift, but it's quite important, right? When many or maybe even the majority of 21-year-old founders with a laptop and an idea are starting to aspire to build something industrial, some physical products rather than software. Like the outcomes of that shift, if it lasts, I don't know if you think it's going to last, but if it does, are going to be quite significant, I would imagine.
Yeah, for sure. I mean, it's a meme now, and it's seen as desirable to try and do something that's at the limits of your ability. It's a good thing, and yeah, I know, you know, dozens of founders based in the EU, based in Germany, working on all kinds of hardware technology. You know, they're patriotic and they're staying there at least for now. But really, here's the thing: it's hard to interpret the level of governance disinterest and kind of regulatory malice that they deal with on a daily basis as anything other than contempt, right? And so you got all these brilliant people who are quite mobile, who would really not struggle that much to get a visa to come work in the United States, and they're working on a salary of 55,000 euros a year with 60% taxation, right? To work at a business where their government like intervenes between them and their boss and says, no, you must not work more than 40 hours a week under any circumstances. Right? You may not attempt to capture any upside for your unusual talents or work ethic. No, you must go home and be cold in the winter. Like, come on, it's bullshit. People, like grown adults, should be allowed to contract their labor as they see fit. Yeah. I wrote a blog post about this a couple of weeks ago, where I was talking about the Laffer curve and the point, like basically titrating government taxation and spending somewhere between the point of maximum revenue and maximum growth. And unfortunately, I fear that you know, in a lot of the West, actually, that the government has grown to the point, and it's non-productive spending has grown to the point where it's actually beyond the point of peak revenue, let alone far beyond the point of peak growth. So you can have an example like the UK economy, for example, probably is throwing off 3 or 4% net growth per year, but that's all being swept up by the government in the form of taxation and then spent in a variety of things which potentially may be socially valuable social programs and things, although in some cases maybe less so. But in any case, they're not. Basically, like the wealth is being generated by the productive part of the economy by definition, and it is being appropriated by a part of the economy that is not productive by definition. In some cases it is, in some cases it isn't. And so that's wealth that a certain amount of redistribution is necessary, I think, for the validity of the social contract. But at the same time, the social contract doesn't just include the people who are alive today and the people who are working today. It also includes the people who are yet to live. And promising a great future to the grandchildren of today's people who work in the UK requires that actually you don't burn all the seed corn. You actually have to plant some of it as well.
Okay, so the conditions in the US are not perfect, but seem to be significantly better on this front than in Europe. And so do you think, as a result of this industrialization trend, are we going to go, or is US going to go full circle from Standard Oil and US Steel ruling the economy through to Google and Facebook now, like back to industrial giants being really the main game?
Well, it's kind of a question about aggregation in factories and mass production. I think this time around there's actually a higher forcing function for disaggregation, because if the primary source of energy is solar power, that's much more democratized than like who has monopoly access to local coal mine, for example. And also our production technology is much more versatile than it was the first time around. So for example, it's easy to imagine a relatively small plant that is much more vertically integrated, making a much wider variety of end products on much smaller production runs, much shorter timescales, with a much more dynamic and highly trained workforce and a lot more automation. I think it's a good thing overall. From Europe's perspective, I think the thing to worry about is that the United States kind of periodically turns inwards and focuses on itself, and it's definitely basically been in that process for the last 35 years. And I don't see that process slowing down. The challenge for the rest of the world is that the United States is large enough to be its own everything, to be its own major economic power and economic bloc. It doesn't have to go outside its own borders to find raw materials or markets to sell into. Whereas, arguably, like the rest of the world combined could probably do that as well. Which is, basically, I think the United States has pretty much lost interest in. I don't personally feel this way, but the United States polity in general has lost interest in involving itself overseas, as it has for the last 70 years.
But within the US itself, you're saying 20 years from now, the next Mag 7 largest companies are not going to be all Teslas and SpaceX's. Most of these new industrial companies are going to be more small and fragmented, and it's still going to be software or AI that have got the largest scale.
That's hard to say. I think that in 20 years, Tesla and SpaceX will still be enormous companies.
But it's not going to be like 10 industrial companies at the top of the largest list.
Well, we talk about Mag 7 right now, but it wasn't that long ago. It was like Mag 6 or something. They could be up to 100 of them, something like that. But yeah, I just think the key thing is like what is the rate of company formation and the growth rate of those companies on the aggregate. And I think there'll be a very, very long tail of extremely prosperous, perhaps not quite as large companies as well, that become the suppliers to these large conglomerates. But in terms of do I think that antitrust law is going to come back and break up Mag 7 into 50 baby Mag 7s and then kind of allow the next generation to grow over them? I don't think that's going to happen. I think VCs have kind of been looking for the next Google for 20 years, and it's still Google. So, Google or Facebook or a handful of other companies. And Google, for all its kind of hilarious weaknesses, still has a lot of mojo, lot of key strengths left.
I don't think they're going to fade away or be broken up. I'm wondering more along the lines of what's the next $10 trillion company like Tesla or like SpaceX that makes hardware that's going to become uniquely possible by cheap and abundant energy?
Well, I think synthetic fuels is a major one, right? So like think about the primary production layer. Like so basically taking raw materials and turning them into the stuff you can buy out of a catalog. Steel, cement, oil, gas and its derivatives, fertilizer and fresh water and steel and other metals, of which the lion's share is synthetic fuel, like synthetic oil and gas. Like the global hydrocarbon industry is something like $8 trillion a year. So if your P over E is 6, then that's a $48 trillion industry. Right now, it's relatively fragmented. The largest company in oil and gas is Saudi Aramco, which has just under 10% market share, and its valuation is in the low trillions. So, yeah, it's if we imagine a future where most of our oil and gas, or at least the marginal growth in those areas, is solar derived rather than geology derived, then it would not surprise me to see that you have a major player in that area, if not 100. There's easily room for hundreds of major players.
We discussed earlier energy becoming abundant to the point of at least feeling almost free or extremely cheap. In such a world, what is the thing that becomes uniquely scarce?
That's a good question. So, I had this blog post just talking about kind of what is the economic picture with AI. Because you can imagine a world in which AI makes some things much more abundant and other things much more scarce. So in particular, if AI increases everyone's economic productivity, but it increases, say, the top 10% of workers' productivity by a factor of 100 and everyone else by a factor of 2, then you'll increase the size of the economy by a factor of 10 or 20 or something, 20, which implies that the price for rivalrous, goods, non-saturable goods, will have to go up, right, by roughly a factor of 20, which means that something like 90% of the economy's relative purchasing power will decline, even as they're wealthier. And I kind of worked through some examples like healthcare, right? So right now you're in the situation where no matter how rich you are and how much healthcare you have, you can always buy more, right? But there's a finite supply of doctors. And so you say, well, how do you solve that problem with AI? And on the one hand, you say, well, we have lots of robo doctors that can now like basically hold Nana's hand and make sure she's feeling fine at all times, which means you've actually you basically created like much more elasticity of supply. And on the other hand, you say AI develops some medicine that makes you immortal. And you stay young and healthy and vigorous forever, in which case you've deleted the need for doctors, or most doctors altogether, right? It's two very different pictures. But the kind of the three major areas that have become more expensive over time rather than cheaper over the last 50 years are healthcare, education, and housing, which is kind of bizarre. Like we're in a situation right now where we're intermediating this conversation between two people. I don't even know where you are, at the speed of light, on a video call using hardware that costs a couple of $100, and that hardware is sitting on a desk. The cheapest I can buy that desk from Amazon is more than the cost of the Turing-complete supercomputer that's intermediating the conversation, right? Why the hell does that happen? Why is a drywall more expensive on a per square foot basis than a big screen TV? Kind of blows my mind, right? And I think part of the reason is basically regulation, like cartel pricing and regulation. So like it's basically the supply of doctors, supply of hospitals is fundamentally restricted. The supply of universities and the importance of certification for access to labor markets is also fundamentally restricted. This is a relatively new thing in the United States, actually. It was not the case even 50 years ago. And then with housing, we've seen the explosion of NIMBYism and more or less bogus environmental excuses. But basically like an infinite set of excuses. They differ from place to place. The outcome is the same. You use them to engineer a kind of involuntary mass transfer of wealth from the non-land owning class to the land owning class. And I think it's probably mostly responsible for the general crash in birth rates. When ambitious 22-year-olds, newlyweds can't buy a house, they can't nest, they can't have children. And we see this problem again in the UK, where the actual fraction of the economy who are working jobs and paying more in taxes than they're getting in welfare is getting smaller and smaller. And these are the same people who are expecting to have children, so that there'll be a strong tax base in the next generation, and they're just not. The birth rate is crashing. And the solution to these things is obvious, right? It's right before us. You have to increase supply. So maybe the easiest way to increase supply in healthcare and education is just through like AI and innovation and medicines and synthetic intelligence. But with housing, I think fundamentally you just have to get out of our way and allow building in new places, build new cities. Somewhat tricky situation because a lot of the houses are owned by retirees who've poured their life's earnings into servicing these kind of inflationary assets, and they have no other options. They can't go back to work. So if you deflate the value of their houses to the point where young people can actually afford to form families and have children, that's probably roughly a factor of 4 or 5. Then these people's retirement nest egg is destroyed, and there's no backsies. Right? We've dug ourselves a massive hole with our mostly tax policy over the last 30, 40 years. There's no real easy way to get out of it, unless we invent drugs that keep people alive in good health essentially indefinitely, and then they can work without it being an excessive burden to themselves. Yeah, it's a tricky situation.
It is a tricky situation, but I guess education and healthcare can be relatively easily solved by AI eroding those human labor costs.
If we allow them to. Right, what we're already seeing is like AI is banned from school, right? Just like Wikipedia used to be banned from school, or calculators are banned from school. And what are we seeing? Laws in place to, we've seen this in entertainment. You can't use AIs to write scripts or to synthesize actors or whatever, because you've got to protect the rights of the Writers Guild and the Actors Guilds and so on. And the same thing we're seeing with doctors, right? Like basically laws being put in place to make it harder for the AI companies to provision healthcare information to consumers. So legal liability, for example, at the same time as doctors are routinely using ChatGPT themselves. So instead, like basically allowing the doctor class to monopolize access to this source of information, which is was not invented by them. I think that information is so fungible that these attempts will not be seen as very successful. Just as we've seen the failure of the walled garden DRM digital rights management on TV, TV properties and streaming and so on, basically fail. They tried to do it the hard way and they failed, and so then they made it easy for people to comply with Netflix and other subscriptions, and they saw a successful model there. But yeah, with housing we're really screwed. Like it's unbelievably dumb. We've had this technology for 10,000 years, and we've decided to make it artificially scarce for no reason, and it is literally destroying our civilization.
It's an interesting thought experiment. So assuming, we solve that regulation when it comes to the services, and like you said, cognition continues becoming exponentially cheaper, and everybody has got even better, faster supercomputers at their fingertips, basically for free, doing their bidding. But basic physical things, maybe like tables, as you mentioned, become more scarce and more expensive. I wonder what that kind of world really looks like.
Well, I think this is again a problem we see in stark relief in the EU, which is you regulate an existing market, and without really intending to, you bake into that regulation an assumption that we've already reached the peak of possible efficiency, and there's nothing further to be gained, and that becomes a self-fulfilling prophecy. And so you cut yourself off from the upside, right? It's a well-intentioned process to try and limit downside of new technology, for example, but the overall effect is that you just reduce variance, and so you reduce the possibility of your civilization to also kind of have out of distribution upsides that kind of come unexpectedly from the basic R&D and stuff that our taxes fund.
But it's probably not regulation and red tape that's making physical objects like furnitures, tables more expensive, is it?
Well, maybe in the peace and quiet of your own evening, you can ask ChatGPT, what are the set of regulations that household furniture suppliers have to comply with in order to be able to legally sell their wares in certain markets? And I think you would get a bit of a shock. I mean, like during Brexit, they talked about the pillowcase law, right? So like there's like just to build and sell, just to manufacture and sell pillowcases, for example, requires complying with like multiple different swaths of regulation on child safety and use of various dyes and treatments and fire safety and a bunch of other things. The crazy thing is that if you have the patience, you can actually go through all these regulations end to end, and many of them are pretty self-contradictory. So you can end up basically all these things just become a de facto tax on producers of things in society that they don't necessarily add value, or they protect against a very remote downside. One of the things that frustrates many people here in the United States is that many of the United States' older cities are relatively walkable because they were built before the development of motor cars and personal cars. And they have these beautiful old, say, brownstones in New York, for example, with single-access stairways and nice windows and cross-flow ventilation in the apartments and things. All these buildings are illegal to build under current law. Illegal. You could not build them. You could not get permission to build anything like them. If they fall down or they get demolished, you can't rebuild them. The actual structures that are legal to build under current regulations are these, they're like soulless boxes that are objectively worse for your health.
A lot of these regulations are very stupid, but even assuming we deleted all of these regulations, when it comes to physical goods and objects, we will still have costs of production and shipping, which will probably continue declining slower than the costs of cognition in the AI revolution.
Yes, I think it is true that long term, well, at least for the foreseeable future, AI will get cheaper faster than these physical goods and products. Again, like that's kind of a challenge for us humans, right? Like how do we remain economically relevant in a world where you can produce the same economic output with 1/10 of 1% of the electricity?
And I guess that's a continuation of the same cost curve that we have already been on for the past 50 years, with computing, because of Moore's law, becoming cheaper, and thanks to the internet and speed of information travel versus everything else.
Yeah, I think the key difference is whether and to what extent the humans who are part of the system are above the API or below it. Above the API means you're the person doing the dispatching, you're the person doing the work, and the computer is the tool that you use. And below the API means that the computer is your boss, and it's telling you to like put the widget in the hole and pick up the driver and drive them over, pick up the passenger and drive them over there.
What do you think is the most likely scenario here?
It seems to me that the economic forcing function seems to be in favor of substituting below the API labor with machinery as fast as possible, rather than most of the above the API labor. But also the boundaries are getting somewhat blurred, aren't they? We'll have to see. But the great future for humanity is one where every human has access to the equivalent of a million other humans who do a lot of the cognitive work for them. This is actually particularly exciting for the people whose particular skills and attributes are not necessarily valued by our current tech stack circa 2025. These are people who in our communities 500 years ago would have probably found high value occupations within that social setting, and today they can't because they can't do math or whatever. Or just like, again, another aspect of the kind of regulatory state is that the degree of regulations and rules around basic functions of life are so complex that I struggle to navigate them, and I'm actually pretty smart. And like your average person who's down on their luck, now they go and fill out a 200-page form in order to get access to some key medical service they need or some key housing service they need, right? It's basically impossible, right? This is people falling through the cracks, and it's not a problem, right? If your ability to navigate these systems is intermediated by your own personal network of hyper-intelligent AIs who are working on your behalf, then the relative detriment of just being born with less brains than your fellow human kind of go away. That's a great thing, right? We've already seen that in other areas, right? Like people who are born with certain medical conditions can be effectively treated and cured now, and they don't have to they've been emancipated from bearing that burden for their whole life. People born with weak arms, it's no longer such an issue because they have access to tools and cars and things. It's a great equalizer. Old people who are, their legs don't work so well, they can drive cars and still have active social lives and participate in their society and help mentor the next generation. Things are generally getting better in this way. And so I think that's certainly a huge positive, in addition to being, a very powerful tool for, if I may humbly call myself the intellectual elite, the people who are doing a lot of the work, a lot of the inventing. The flip side is, at some point, we better damn hope these machines decide they want to keep us as house cats. a little bit like the culture series by Ian Banks, or we have to figure out how we fit into the grand scheme of things.
The final great equalizer. Which of these scenarios do you think is more likely? The wildly optimistic one or the opposite?
Oh, I'm very much optimistic. Easily 90-10 in favor of the optimistic scenario. I think that all the worst things that could happen to humanity at this point are firmly in human control at this point. So we're talking like a nuclear exchange over Taiwan or something, right? Just like dumb, didn't have to happen. Will set us all back decades, if not centuries. Like let's focus on the upside, the future. We've got entire planets out there that are within reach of humanity, and we can go out there and build a fabulous future for everyone. And AI can certainly be part of that picture, I think. So that's part of it.
What is the one thing you would be working on right now if it wasn't energy?
Immortality. Like it's kind of easy to overlook. Even if you take the climate doomers predictions at face value, the impact of climate change will be measured on the order of like millions of lives lost per year at worst, which is certainly like not a small number, but 100 million people die every year of old age and all the diseases of old age. And generally speaking, they're not pleasant, not a pleasant way to go. A lot of these people, they don't want to leave. They leave behind friends and family who love them dearly. They get to watch their own faculties and health decline slowly over time, or they get to watch their loved ones do that, knowing the same is in store for them. It's kind of this unthinkable horror show, really, and we lock it away. Right? We put these people in old folks' homes, and we don't think about them too much because we know it's coming for us. But why? There's no intrinsic reason for it. Like we use rats as model animals, in part because they age 50 times faster than we do, and so we can kind of see the effects over the course of a lifetime of various drugs and stuff for them because they age and die in a couple of years. But rats and humans are so similar that if you look at their tissue under a microscope, you can't really tell the difference. And yet, for whatever reason, we age 50 times slower. I say, well, if we can age 50 times slower, why not age 500 times slower? What's it going to take? There's obviously some minor genetic differences here and there that cause us to age more slowly. And I think that I'm not the only person to have noted this, but it would be worthwhile figuring it out. Here's the crazy thing. I'm pretty sure that when we figure out what drug it is that actually slows down aging by enough that we can then move in that direction pretty decisively, it will turn out to be simple enough that we could have been synthesizing it since the 1930s. So we'll be looking back on a century of people dying for no reason. It's kind of like the last works lost before the invention of the printing press or the photocopier, right? Like if only the ancient Romans had had a photocopier, imagine what we would have now.
So infinite energy, space travel, immortality, that's the world of abundance that we are, or we should be building towards and are hopefully on the verge of unlocking.
Yeah, that's the upside that's on the table, right? We spend an awful lot of time worrying about reallocating some tiny marginal piece of scarcity from here to there. And we should just be saying, what if we just deleted that scarcity entirely forever?
I feel like, yes, unfortunately, for some reason, the vast majority of population is trapped in this zero-sum game scarcity mindset. And they don't really have this mental model for the economy can grow, all boats can be lifted. And that just seems very counterintuitive to grasp for some reason, I guess.
I mean, I agree that I think most people don't think all that deeply about how their stuff gets to them, how it's made, and so on. And they don't have to. And in some ways, the fact they don't have to is a wonderful thing. But I think it is incumbent on our leaders to be technical enough to understand how the wealth of their societies is actually generated and to make sure that they don't strangle it in the crib. It's really important.
Yes, they should probably be teaching at least some of this in school, which I don't think they're doing enough of.
How many people do you know who work in factories?
Basically none.
Like relatives, friends, parents of friends, anything like that?
Not relatives, not friends, no.
Exactly. How many people do you know who are farmers?
Same, basically none.
It's interesting, isn't it?
What are you getting at?
Well, it's difficult to have really any intuitive understanding of the means of production if you don't know anyone who knows anyone who actually does it.
It's fair.
So maybe like in order to be eligible for the EU Parliament, you have to have worked in a factory for a year or something.
But I don't think the average factory worker has any better intuitive understanding of the economy growing for everyone if you do the correct things versus you having to take away from someone.
No, I agree with that. I'm just saying it would be a good thing if our leaders had come from a wide variety of walks of life, particularly on the industrial side, given its key importance.
Fair enough. So let's get more people who understand the space in the right roles, and let's make all of these unlocks that we discussed. I guess that's a fair point to land it at.
Yeah, sounds like an easy plan.
Sounds much easier than it is, I'm sure. Okay, Casey, thanks a lot. This has been great.
Yeah, thanks for having me.